Okay, I went ahead and start recording, and so chapter 5. What we're going to talk about today in JavaScript is troubleshooting, and in that in that concept of troubleshooting, I will tell you as someone who's been working with a lot of JavaScript over many years, always at an introductory level, right? I'm always helping students learn. You know, I will say that my troubleshooting skills have gotten sharper over the years. And so, the reason I bring that up is to realize that troubleshooting is a skill, and as any skill, when you're a beginner, you're not good at it, right? So if you view troubleshooting as a skill, and realize probably as a beginner, you're not the best at troubleshooting. And that over time, that skill should be worked on. And that just kind of happens naturally when things are broken in software and you're tasked to fix them. So the assumption is today in my class in front of me, it's a class full of roughly beginning level JavaScript developers, and you're all pretty bad at this skill, right? And that over time, over years of time, the goal is to become better and better and better at this skill. Okay? So what can you learn in this chapter that will make you better? Well, we're going to introduce some tools that will help you to troubleshoot. Okay? And as you write more and more JavaScript, you'll use these tools, you'll begin to use these tools, and I will even say at first, these tools will feel uncomfortable. You're going to say, I don't understand these tools, I don't know how to work with these tools, I'm going to shy away from these tools. But only through learning to use these tools, getting comfortable with these tools, and actually using them, will you learn to be a good troubleshooter. And that's going to make all the difference in the world, considering that's a large part of our job is to fix bugs. So with that in mind, one of the first things I want to do today is I want to expose what I think is the most common bug for beginners. Without a doubt, I would place a bet that most of you have seen this already. All right, I just want to kind of bring this one error to light, as what I think is the most common bug in beginner JavaScript. See this all the time. I see it on a daily basis. And then we'll kind of break down and talk about the different kinds of bugs, right? Because when we're troubleshooting, obviously we're fixing bugs, we're squashing bugs, we're fixing problems in our software. But I want to kind of start with this first common bug that I see, and I think is the most common I'm not even going to wrap in my bootstrap here. I'll go with input type of text. Label for txt input. ID is txt input. Name is txt input. And a button as soon as I say I'm not going to wrap in Bootstrap. Got to wrap in Bootstrap. Let's bring in the CSS. And the JavaScript. Okay. Big old long text box. Okay, let's go ahead and do a, so, kind of the first thing I just wanted to do is a quick demo of the most common bug for beginning JavaScript developers. And so here we've got a simple form. In fact, I don't even have a form tag. Let's go ahead and bring in a form tag. That way all of our form controls are nested in a form tag. And let's target button click. So this is the ID of button submit. And let's go ahead and target document. We'll use query selector button submit dot on click equals an anonymous arrow function, something like this. And let's just console.log timeout. Okay, so let's wire this up and take a quick look and inspect in the console. Now, right away, my console has errors. So let's kind of start at the ground floor, right? As someone who's learning to write JavaScript, you have to even know that the console is your best friend, right? So that's kind of, in troubleshooting, the first thing to learn is like, how do I begin to look at my own code to try and diagnose problems? And so you have to understand, I think everyone in this classroom at least understands at this point, the Elements tab over here is where we can kind of look at the HTML and the CSS. But the console is where we're going to begin to start looking at our JavaScript and maybe some of the errors that are being thrown by our JavaScript. And right here is a demonstration in the console window of what I see as the most common error, right? Literally cannot set properties of null. So by a raise of hand, how many in this classroom have seen this error at least once in this class? Okay, raise your hand if you're seeing it. So if you're not raising your hand, either you're not paying attention or you're genuinely writing perfectly clean JavaScript, which is probably not the case. So this is, I still do this all the time. Okay, you've seen me make this mistake all the time. And this is an error that is thrown. And so cannot set properties of null in JavaScript is what I think the most common error for beginners. And I wouldn't even lump beginners because, again, I don't label myself as a beginner. I've been doing this for a long time. And yet I make this mistake all the time. So what is going on here behind the scenes is we're just not selecting our HTML appropriately, right? So it says cannot set properties of null. So if I kind of look at our code here, this on click is a property. So it's trying to assign a property of something that is null. So what that's saying is to the left here, this is returning null. This selector, this query selector, is returning null. So there is no on click of null. And really what this is saying is that the way that we're selecting our HTML is not working. And this can happen when we're wiring up an event handler or when we're inside of an event handler. It can happen in a lot of different places. And so what you might remember about this query selector is that it utilizes what we've learned in CSS. How do we select things in CSS? Well, we select things like classes. We prefix our classes with a dot, and we prefix our IDs with a pound symbol. So this ID needs to be prefixed with a pound symbol. Okay, so just kind of start off there. And now when we go to the console window, we don't get that error message. We can click submit. We get our console.log hi mom. Okay, so I just wanted to start there because that's one that I think we've all seen before. And whether you recognize what that's from or not, now hopefully you have a clear understanding. When it says cannot set properties of null, you're probably not selecting your HTML appropriately in your JavaScript. And if I kind of even do something like this, keeping in mind that JavaScript is case sensitive, we get the same error message, right? So now maybe you're like, okay, Mr. G, I already knew that. I've been working in JavaScript now for a couple of weeks, and I've kind of learned that error message means that. But, that's kind of good. So that's fine. So we've covered that basic of what I think is the most common error message that you might see. Let's talk about in software development, this concept of what is a bug versus what is testing. So there's this concept of debugging versus testing. And so, when you're going into the book and you're kind of reading this theoretical concept on how to fix problems, there is a difference between debugging your code and testing your code. And let's first off, what is a bug? Okay. A bug is simply, bless you. A bug is simply, a problem that's been identified with your software, web page, etc. Okay, you're writing code. Either an end user or you yourself, or hopefully you yourself, but if it makes it to the end user, it's a problem. When it comes to types of bugs, generally speaking, there are logic errors, there are runtime errors, and there are syntax errors. So, you can kind of say, okay, a bug is a problem, and that problem can be classified into 3 groups. Okay, when you identify a problem with your code, that can be identified into one of these 3 areas. A logic error is a bug or a problem with the programmer's solution to a problem. There's going to be a problem that you're trying to solve, and you're going to come up with some lines of code, some algorithm, if you will, some process for solving that. And you might not solve it correctly. Your brain, tried to solve this problem ultimately incorrectly. So the code that you wrote wasn't right? And so a lot of times, you can kind of break this down and say, well, hey, the problem required the user to, maybe a simple example, you were supposed to add, but instead you subtracted. So the real world problem required you to solve it in the real world by doing addition, but you mistakenly solved it with subtraction. Well, that's a problem with your logic. Your logic is not leading to the correct solution. Okay, so one kind of bug is considered a logic error, and in large part, that comes down to the programmer's logic. Now, part of learning to program is to learn to solve problems, in a unique way. Like, you are literally, the more you program, you're training your brain to solve problems using this computer. Your brain will be taught to think logically. Okay, as you are learning to write software, you will become a more logical thinker. It is a great tool that everybody should go through in their lives. That's why they're saying teach code to kids. Because the more you learn to solve problems with code, again, your brain will think more logically. You'll train your brain. You'll wire your brain to think more logically. Okay, so that's a great benefit of learning to code. Okay, but part of that will be to make logic mistakes, and that's just one kind of bug. Another kind of bug is a runtime error. I'll give you an example of a runtime error. The web page needs to connect to a database, but the database is down. The server is down, but the server is down. That's not a problem with your code necessarily. Your code is fine. Your logic is fine. But the user credentials, the username and password are saved in a database. How are you going to log in if the server is down? Okay, that's an example of a runtime error. There's really no problem with the code. You just need a database admin to get that server up and running. Right? So that's an error that most of the time the code is good, but there are conditions like databases and maybe like resources on the server. Maybe in the old school days, like servers used to run out of RAM, out of memory errors, or out of hard drive space. Maybe permissions issue. The user's trying to write to a file that they don't have permissions to do that, or trying to access a read of a file they don't have permissions to. And so these are all examples of runtime errors. And then there's syntax errors. The great thing about syntax errors, they typically don't make it into production because your code simply won't run. So syntax are the rules of the language. Okay, when you're talking about programming syntax, where do the semicolons go? Is it case sensitive? Where do the periods go? Where do the double quotes go? Where do the single quotes go? In English, we have a syntax, right? Where do the periods go? Where do the question marks go? Where do the commas go, right? All of you have taken an English class where you learn the appropriate places for all of those punctuations, right? Well, English has a syntax. every language has a syntax, right? I don't speak too many, like I try to speak other Spanish. I've studied Spanish. Spanish has its own syntax. Where do the punctuation symbols go? JavaScript has its own syntax. If you don't follow the rules of the language, it's not going to run very well, if at all. Yep.
Depending on which portion of the world that the Spanish is in,
Yeah.
punctuation can differ.
Yeah, and if I was a better Spanish speaker, I would know all those rules, but I don't. And even as native English speakers, how well do we understand the punctuation, the syntax of English? Right? Yeah, we don't. Like, as a society, we don't. But that's okay. Point is, those are the three kinds of errors. When I say errors, you could refer to them as bugs. By the way, the lore behind the concept of a bug, why is it even called a bug? The lore behind that is, if you go back to the days of computing, when computers were literally the size of this room, right? In the old days, computers were huge. And some programming instructions were fed into a computer the size of this room. And they thought that the programming instructions were good. They didn't think that the code was a problem. And so but it wasn't outputting correctly. So to fix the problem, they had to like go into the room and make sure all the cables were plugged in and make sure all the machinery was working how it was supposed to. And the lore is, at least, they found a moth in between a read and write head of a hard drive. Like, they literally found a bug in the hardware of the computer. And in order to fix it, they had to remove the bug. They had to debug the hardware, and fixing that, removing the bug, thus fixed the problem. So that was bug debugging. That's the concept. So now you know. Did I say syntax errors? I meant syntax errors. So that's why they're called bugs. At least that's the supposed reason. And errors. Yeah.
So runtime is just some resource isn't available.
That's an example, of a runtime error. A lot of times runtime is, the idea is that normal operation, it's up and running, but then during the running of the software, it crashes. That's more broadly the theory there. It's often the case that logic errors, sometimes these things intermix a little bit. Like, could your logic error cause a runtime error kind of thing? But the idea is that normal operation, the software is up and running, it's functioning normally, and then it crashes kind of during the normal execution. In other words, you've fixed the logic errors and you've fixed the syntax errors. It's up and running, and it crashes when it's running. Okay, so those are the types of errors. And again, when I say a bug or error, it's a synonym, right? They basically mean the same thing in this case. An error and a bug, basically the same thing. But then to kind of get back into debugging versus testing. Okay, so to kind of take a step back, what's the difference between debugging and testing? Well, debugging is the process of removing errors from your code. Whereas testing is the process of locating errors in your code. And I'm not typing very well on this Monday morning. You all should be manually testing the code that you write, right? So all of you are writing some JavaScript. That JavaScript is solving some problem, like calculating the order cost, right? You're calculating an order cost, and you want to manually test with various inputs, right? You're going to say, okay, I want 10 cheeseburgers. Now I want 5 cheeseburgers. Now I want 3 cheeseburgers. I want 10 fries. I want 2 fries. I want 1 soda. You want to provide various manual inputs, and that is an example, manual testing of what you're going to be doing all semester, right? So testing is the process. Now, there are jobs in this industry for testers, right? So there's literally a job. Little known fact, maybe you guys know this, probably you don't. I have a sister, and my sister went through this program, and when she graduated, she doesn't write code on a daily basis. But what she does is she tests code. My sister graduated from this program and became a tester. And so a tester is someone who's in the software development industry. They're not writing code, but they're looking for problems. Okay? And it really helps when you have a coding background to understand maybe what's causing the problems. Okay? So it is in the umbrella of software development to be a tester. And that's in fact what my sister does on a 9 to 5. She works for Ameren, as a tester. It's a very normal job in this industry. It's kind of what I would call it like the help desk equivalent of this industry. Like it's an entry level position for this industry. The difference between the testing that we do in the classroom and what she does in the real world is she uses software to test code, right? And so instead of manual testing that we're doing here, she uses software to provide inputs for the software and then provide outputs. And so instead of manually testing with like 4 or 5 inputs as you do for your software, they write software. They write software to test software. So instead of manually providing 5 inputs, they write a little bit of code that provides 10,000 inputs or 100,000 inputs or 1,000,000 inputs, and then make sure that the outputs that they receive from those inputs are the right outputs, right? So testing is like her job. You might have heard of QA testing. QA stands for quality assurance testing. So again, they write software to test software because it's much more efficient that way, right? So again, now hopefully you begin to understand there's a little bit of a difference between testing, manual testing, and automated testing versus debugging. Debugging is the process of not finding problems, but fixing problems. So high level, testing is locating the problems with your code. Debugging is fixing the problems, right? So it could be that simple, right? Testing is finding the problems. Debugging is fixing the problems. And again, big companies have teams of testers, right? Teams of multiple teams. They might have a tester for the mobile app, and they have testers for the web app, and it's not so uncommon for the developers to dislike the testers because the testers are always saying, no, your code sucks. Here's your code sucks. Here your code sucks, because they're finding all the problems with their code. So developers are often frustrated by the testers because they're being told all the problems with their code, right? And that's kind of the stereotype of why, why one industry kind of doesn't like the other kind of thing. Okay. Yes.
Does it make sense to test your code before submitting it as a finished product?
Yeah, and so that's pretty normal, is that you will go through testing. The code that you write will have to pass some of these QA tests before it can launch. So depending on the company, they'll have that in place. Probably bigger companies that have a lot of money behind what they're doing, they'll have QA in place. So that's just some high level theory, debugging versus testing, types of bugs. Okay, these are the common types of bugs. And then really the most important piece of all this, besides this theory, is understanding what tools should I learn to be better at troubleshooting or debugging. Troubleshooting / debugging. And so, again, the most useful thing, the most practical thing that you'll get out of this chapter is getting exposure to a couple of different tools. And let's go ahead. We already demonstrated the console window. The next tool that I haven't exposed you to will be a breakpoint. And then we will go through troubleshooting, Windows. And so there are various windows called like the local windows and the watch windows. And so this is like the locals and watch windows. And so really that's in order to get here, in order to get into breakpoints, we're going to look at some different tabs in Chrome. Okay, so I already demonstrated the console window. This is where you're going to get a list of JavaScript error messages. In fact, I would go back. It's not a bad idea to go back into some of the earlier HTML stuff you did, like maybe your midterms, and like just pop open the console window to see what kind of errors are being thrown by the JavaScript, right? And can you clean that up? Because these errors are ultimately something not working on the JavaScript, and maybe you don't even need that. So can you comment out some script that's throwing some error that would slow your page down, maybe on load or while it's running? So let's we already looked at the console window. Let's look at the most beneficial tool that I think is the most intimidating for beginners to use, which are these concepts of a breakpoint. And so this might be the single most useful tool that people just freak out about. They don't know how to use it. They don't understand it. They don't like it. It's uncomfortable. And yet it's the most useful. It is incredibly useful in troubleshooting. So again, as you become a better troubleshooter, as you learn to fix problems better in your career, I have confidence that you will get comfortable with these breakpoints. And so I'm going to start off here by maybe just writing a for loop. And this for loop will start off at 0. We'll loop less than, let's just hard code in something like 10. And let's output the index into like a little H1 with an ID of output. So we're going to create a loop. This loop is going to loop 10 times, 0 through 9. And each time through the loop, document get, we'll use query selector, ID of output. inner HTML plus equals template literal with the index. Bless you. Okay, so we're putting in a loop, and this loop is working, so we're not really troubleshooting anything here. But what I want to do is introduce a couple of new windows. And so when I click inspect, we've kind of seen the console window. And the next tab over is this sources window. And so this is going to be a new window that we're going to start experimenting with. It says Control P will open a file, run a command. You can also open the file by kind of navigating into the JavaScript and double-clicking bug.js. Okay, so we can actually open up our JavaScript files in our browser. And this will let us do some troubleshooting. And so, the first thing behind understanding what a breakpoint is let's actually see what it is. It's kind of this, in the margin here, you're going to need to know how to create a breakpoint. And so if I click on the number 4, or if I even click in this white space next to the number 4, I can set a breakpoint. Now it's interesting, I can't set a breakpoint on every line. Notice like line 6, I can't create a breakpoint there. And the reason is because like line 6 really isn't executing. I could put line 6 on its own. Like I could put it on line 5, for example. So you'll notice like where the semicolons are. Like these are places where I can, at the end of, now there's semicolons in my for loop, which is why it kind of lets me set a breakpoint there. So generally speaking, wherever you see a semicolon, you can also put it on event listeners, because that's terminated with a semicolon. This on click is terminated with the semicolon. So, how do you create a breakpoint? Well, you're just going to click on the line number. That's kind of the first point. And what is a breakpoint? We're going to get into that. But it's just worth noting that often beginners get frustrated because they can't set breakpoints on every line. Like I can't set a breakpoint on line 3. Well, that's just how they work. You can't do that. Typically, you need a semicolon on the statement. You could put it on a statement terminated with a semicolon, but you can't put it on any line. Okay. So let's just, for the sake of this, demonstrating this breakpoint, because we all have some comprehension of how a for loop works. And if this for loop wasn't working the way we would expect it to, you might set a breakpoint to troubleshoot the for loop. And so if I come into here and click on the submit, now you're going to notice it says paused in debugger. That's because I have a breakpoint set and the breakpoint has been hit. Now notice visually what's changed. Visually on my screen, line 4 has been highlighted in blue. Okay, before the breakpoint was hit, that line was not highlighted. Okay, in fact, if I just click on continue, if I click on resume, I can click it right here, or I can click it right here. It'll just run the script, and notice it'll append 0 through 9 again, because that's the code that I have written. Okay, so by default, it's not the entire line that's blue, it's just the breakpoint's line 4 that's kind of there. As soon as the breakpoint is hit, it pauses the execution of your script. Why this is so great is because it's going to let you go line by line through your script and see what's going on. If your code is executing the way that you think it's executing. Okay? By the way, one thing that I skipped over, most of the time, if you guys are following along, zone in on this concept for a second. Most of the time when you write your own code, the first thing you're going to do is not put a breakpoint in. The first thing you're going to do when something's not working the way you would expect it to, is you're going to go right back to the source code and you're going to look at it. You're going to look at your source code before you put in a breakpoint, because that's just the natural, like, well, I wrote the code, the web page isn't making it do what I want it to do, so what's the problem? And I will tell you, most people, they say, well, it's a problem with my computer, it's a problem with my browser, it's a problem with anything else besides me. That's people's gut reaction. Okay? You have to get past of that gut reaction. Most of the time, if it's not working, it's not because of the computer you're on or the network you're on. Most of the time, as beginners, the code that we're writing, if it's not working, most of the time it's because we are the problem. Right? We are beginners. We are learning. It's not a problem with the outside world. It's a problem with the inside world. The problem's between the keyboard and the chair. You ever heard that one? The problem exists between the keyboard and the chair, aka you. Look at the man in the mirror. You're the problem. Okay, now that we understand that, it's probably us, because we're beginners and we're learning. It's probably us. The next thing to do is to go to look at the code. Well, here's the next problem with our brain. The first problem with our brain is that we don't think that we're the problem when in fact we are. The second problem with our brain, as we look at our own code saying, okay, it might be me, I might be the problem. Do you know what we tend to do? We tend to not look critically at our own code. We still, even though we say, okay, I might be the problem, let me look at my own code, we still tend to go, I don't think I'm the problem. I'm going to look at my source code, but I still don't think I'm the problem. We don't look critically at our own code because subconsciously we're still thinking, I'm not the problem. Okay? Now, that is so common. And you guys have seen little brain tricks like this before, that just as an example, when you're reading a paragraph, if every letter in a word isn't there, you can still kind of read a paragraph even if every word isn't there. Do you guys know what I'm talking about? Like, what is that called? I should know what that's called. But like, if you just have a paragraph of text, like every letter isn't there, but you can still more or less kind of skim it and read it. Do you know what I'm talking about? You can still skim it and like, okay, I understand what they're saying, even though that E isn't there or the A is missing. It's still not there. That's how we look at our own code. We skim it. We don't critically look at our own code. That's why as a teacher, or maybe your lab partner, when your teacher or lab partner looks at your own code, you can look at a problem for 20 minutes, but you're not looking at it critically. You're skimming it. But when someone else, a teacher or a lab partner who understands the code, they can look at it and maybe find it in a split second. They can find your error in a split second because they're just starting from the base of like, I don't understand anything about your code. So like, let me look for the missing semicolons or the missing quotes. Okay? So problem one with our brains as humans is we don't think that we're the problem when oftentimes we are. Problem two with our brains is that we don't critically look at our own code when we should be. Okay? There's a fun little thing behind this. This rubber ducky troubleshooting. Okay, this is kind of a fun little thing here's the theory behind rubber ducky troubleshooting. Okay, the theory behind rubber ducky troubleshooting is that you place a rubber duck on your computer. Okay, like as displayed on this picture, and you have to explain to the rubber duck your code. Line by line, explain to the rubber duck your code. Why is that? Why would in the world would you do that? It's because it makes you very line by line examine your own code critically. Right? You're not skimming when you're explaining to the rubber duck your problem. You are going line by line, critically looking at your own code. And when you do that, when you critically look at your own code line by line, you're going to go, oh, there's my problem. Right? So that's kind of a fun little thing. I had a class some years ago, and they had fun with this. They bought like 100 rubber ducks, and they had rubber ducks on their keyboards every day. And I just thought that was kind of a cheesy but fun thing to do. So to kind of, bring this back in, you have to train your brain to look critically at your own code and recognize it's probably your code that's causing this problem, and to not skim your code when you're looking for problems, but to critically look at your code line by line for the mistake. So here we are, we're back in our breakpoints, and it's like, okay, the first thing that I did when I'm troubleshooting is I go back to my source code and I critically look at it line by line for a problem. And you're going to do that for some number of minutes, okay? And if you can't solve it just by looking at it, that's when you're going to use a tool like a breakpoint, right? So I guess if I'm just kind of being honest about how most developers do this, you're going to look critically at your own source code for some length of time. You have to be the judge. 5 minutes, 10 minutes, maybe 30 seconds. You have to look at it and see if you can find the problem. For me, it's pretty quick nowadays because I realize when I'm just looking at my source code, I'm probably not taking a very critical look at it. If I want to take a critical look at it, breakpoints really help you look critically at your code, right? More useful than rubber ducks are breakpoints, because that's exactly what a breakpoint will do. It will execute your code line by line, and you can watch your code as it executes, line by line. So rubber ducks, the theory behind rubber ducks is that you critically explain your code to the rubber duck. The breakpoint is, no, we're going to walk you through line by line your code and step through your code, and you can watch it execute and unfold. So step one, look at your own source code. Step two, pretty quickly, look at the console window for errors. And after that, you're going to consider adding a breakpoint, adding and using a breakpoint. So back to the breakpoint. When you see this blue bar going across, you're going to notice, and let me kind of pull this up onto the screen here in case you're watching on the projector. Okay, these controls over here, there's 1, 2, 3, 4, 5, 6, 7 buttons. All right, I got that right. 1, 2, 3, 4, 5, 6, 7. Okay, plus all this stuff going on here. There's no doubt there's a lot going on in this window, so I understand that it's intimidating, right? On top of these buttons right here, there's all of these collapsible windows right here. So we've got the JavaScript, we've got the files kind of over here, and we've got all these windows. There's a lot going on. It's a busy interface to look at. And I think this busy interface is part of the reason why people are so intimidated by breakpoints. If I just hover these tooltips, notice it says step over next function call. So that's often called the step over button. Okay, the idea behind the step over button is that if you want to go line by line, you might go into a function, right? If you know that the function might be a problem, you might go line by line through the function and watch that function execute. But sometimes there's a case where you know that function's not a problem. You don't think that function is causing your problem. So you might want to step over the function call. In other words, skip over it. Right? So that's what step over is. You don't go into the function, you skip the function. This next button, though, is probably the most clicked button when you're in a breakpoint. Okay? It looks like F11 is my hotkey for this. This is the step into function. This is how you execute your code line by line. You want to watch your code line by line execute, you're going to step into. Bless you. So again, if you're following along, taking a look at this button right here, this is the most commonly clicked button when you're in a breakpoint. In fact, let's click it. So notice if I look at these windows, there's a watch window, there's a breakpoint window, there's a scope window, there's a call stack window. If I expand scope, and notice there's block scope, local scope, and global scope. Interesting. We've talked about scope, and we've talked about those three kinds of scope. And so when variables and functions are in scope, in block scope, or local scope, or global scope, you'll kind of see these functions, like notice there's an alert that's considered in global scope. Well, that's a function that you can call. There's a whole bunch of things that are in global scope, so that's a little overwhelming. Let's not look at global scope right now.
Is it reading the bootstrap? Is that what it's doing?
Well, these are all, well, there is some bootstrap stuff in there, yeah. But these are all built into the JavaScript bootstrap, so that's what's going on there. Yeah, these are functions that the JavaScript bootstrap make available for you to work with. But also, like alert is just built into JavaScript itself. So I'm not going to look at global. Instead, I'm just going to expand the block in local and watch what happens as I click step into. Now, I want to point out in my for loop, that line 4 is highlighted blue. But you can actually see right here what is about to execute. Do you see the little blue arrow? Can everyone kind of see where my mouse is? We'll call that a blue arrow. That is the statement that is about to execute. So what is that? Well, that is a declaration of a variable called index and an assignment setting index equal to 0. So as of right now, index is currently undefined because it hasn't declared and initialized that variable. But as soon as I hit step into, it will declare and initialize index. You can actually see index is now a variable that is a block level scope, which means it's in the for loop block. That's the scope of that variable. Now you can see this little light blue arrow indicating that that's the next statement that's about to be evaluated. We're going to test if index is less than 10. Right? So I click this button once. You can kind of see it's about to evaluate index less than 10. Well, of course, 0 is less than 10, so when I click step into, now you can see the blue line is on line 5. It's actually not even really, it doesn't have any sort of visual indicator that's about to execute other than where the blue line is. Now, I will say this is a plugin that I have in my browser. It's going into Grammarly. This is often where people get confused and you come into some other JavaScript file. Notice it's no longer executing my bug, but somehow this other Grammarly check.js popped up because that's a browser extension that I have. This is a little frustrating. Oftentimes you might have to click step into a bunch of times. This clearly isn't getting me anywhere. So I might step over, step over, step over. The next button that I haven't shown you is step out. We're going down a rabbit hole. You guys kind of see as I step into and step over, more scripts keep opening up, and I'm going down this JavaScript rabbit hole. And to get out of the rabbit hole, I'm going to step out. Notice now that brings me back to Grammarly. And this is part of the reason why I understand why people get frustrated behind using these breakpoints, because I just had to step all the way out, and now I stepped out so much that I stopped the breakpoint from executing. So let me just kind of click, 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 and it brings Grammarly in. Let me click on resume. Let me click this again. Now I'm getting this to work by actually clicking step over. So a couple solutions to this. Number one, I could disable Grammarly for the time being, so it quits interfering. So I'll go ahead and do that. Under my extensions,
Probably in settings.
settings, extensions. Yeah, we got extensions right here. Let me temporarily disable this. I'm going to turn off Grammarly. But what I want to, so I've disabled Grammarly, so that'll help. But what I want to point out here is by clicking step over, notice if I'm following the flow, it's doing what I need it to do. I'm following the flow of my program executing through this for loop line by line. It's about to increment index. Index is currently 4. I can hover index and see its current value. I can look at the block scope and see its current value. I can see index now goes to 5 after I execute that loop. It's 5 less than 10. It's about to be evaluated. It is. So then it goes down to line 5. If I click step over again, it executes that and it prints it on the screen. Right? So ultimately what I'm doing here, without that little snafu with Grammarly getting in the way, by the way, that's really normal to have other JavaScript files kind of go down the rabbit hole and have to like climb out of the rabbit hole. Sometimes you might choose to step over a function call. Normally you're stepping into, but ultimately, if I refresh this now, click on submit, let's see if Grammarly pops up now. Okay, now Grammarly's not interfering. Now as I'm stepping into, you can watch my script execute line by line. And at this point, it's done running. And so you can just click on resume. I will say part of the frustration here is oftentimes when you're stepping through the JavaScript, you're going to notice that other JavaScript functions are called, and that's more of an interference than anything else. You just have to learn how to work around that. Which might include disabling plugins or stepping over or stepping out, which are all useful buttons in the first place. So, this is an extremely brief recording, but it was an hour. Okay, I'm kind of keeping this at a high level. I've introduced you to some tools. Those tools mainly are breakpoints, other theories around the types of bugs and how you go about fixing those bugs using breakpoints. Of course, troubleshooting is a skill. It's kind of like me standing up here for an hour explaining how to shoot a free throw. But you're not going to be good at shooting free throws unless you actually practice. Right? That's how I realize that's how you're going to get better at troubleshooting. Of course, that's where the labs come into play. Right? So as we do the labs for this chapter, we'll get some practice. And of course, it's just the beginning of learning to troubleshoot. Okay? Any questions on breakpoints? Does everyone know how to set a breakpoint, step through your code? You understand the benefit of stepping through your code? I guess one last thing that's worth noting. If I kind of come into here, like let me go ahead and declare a variable a, let a equals 5. And I click on this button, here's my let a equals 5. Let me hit this breakpoint. A is kind of a global scope right now. It's not showing up in my block or my local window. It's because it's declared outside of a function. And so to look at variables and inspect variables like A, you can add a manual variable as a watch. And so I can kind of come in here, type in A as my variable, and I can track the value of A inside of a watch variable. So block and local scopes are useful to kind of watch variables in that scope. But as you get into global, somewhere in here you can kind of hunt down the variable A. But oftentimes, instead of digging for the variable, you could just very manually add a watch variable. And these watch variables are very useful in troubleshooting. So I'll leave with that. And if there's no questions, I'll stop where I'm at.